Hello everyone, welcome to Einstein classes. Today we are going to learn about rigid body dynamics. So in rigid body dynamics, we mostly learn the most important, a very important topic, that is moment of inertia. So first thing is that what is the meaning of moment of inertia? Moment of inertia. So like in linear dynamics, we have mass. So how can we define mass? So we can define mass as the ability to resist change in motion. Now what does it mean? It means that if like mass is simply, mass is nothing but inertia. Mass is nothing but inertia. Okay. Now what does it mean? That suppose a car is moving, all right, and suppose we want to stop the car on applying certain force. So definitely we experience some resistance. Like the car start pushing us. It will exert some certain force on us, and it is due to because it has momentum, because it has motion and it has mass. That is called momentum. Alright, so this is the case of linear dynamics. This is the case of linear dynamics, where we say that certain things has momentum, and due to that it resists. Actually, mass is nothing but it resists the change in motion, right? So this is the case of linear dynamics. Now in rotational dynamics, suppose this is a rotating object. Suppose it is rotating about this axis. And now, if we want to stop this object, so we will experience certain resistance, and the ability of a body due to which it opposes change in rotational motion or rotational dynamics is called its moment of inertia. Let us take some more examples. Like suppose we have a door, and if we want to open this door from two positions, position A and position B, this we experience in everyday life. If we open the door from position A, then we have to put a more force, a more effort than position B. Why? This is due to moment of inertia. So two things are clear here, that moment of inertia is nothing but it is the ability of a body due to which it opposes any change in its rotational motion. Any change in its rotational motion. Now, next thing is that how do we calculate this moment of inertia? Because we have just noticed that moment of inertia also depends on the position where we are applying the force, right? So we have a special formula to calculate moment of inertia. Suppose this is the axis about which an object is rotating. Suppose this is an object which is rotating about this axis, and let this distance be r. All right. So the moment of let the object be m1. Let the object has mass m. All right. So the moment of inertia of this body will be given as m r square. This is very important, that moment of inertia also depends on the distance from the about which the body is rotating. So moment of inertia depends both on mass and the distance between the body and its axis of rotation. R is distance between the body and the axis of rotation. Alright, so this is the very basic concept of moment of inertia. Now we have to calculate moment of inertia for different cases, and we will solve some basic problem related to moment of inertia. So this is all for today.